Hi, this is Sheikh Nurjahan. Today my seminar topic is random process and my roll number is 24BQ1A04F2. These are the topics of random process. First one is introduction, definition of the random process and different forms of random process, classification of random process. There are the four classification of random process. First one is continuous random process, second one is discrete random process, third one is continuous random sequence, fourth one is discrete random sequence and their applications of random process. Now I want to tell about what is random process. A random process is also known as stochastic process, is a collection of random variables that change with time. In simple terms, it is a time varying random signals. Examples of the random process are message signals in communication and background noise in a receiver, variations in weather like temperature or rainfall, speech or music signals, etc. Why do we use random process? We use random process to study signals that changes unpredictability with time, such as noise or message signals. We cannot fully know their behavior, only their statistically properties like average power, variance, etc. can be known. Hence, they are described statistically, not deterministically. This is the introduction of random process. A random process is a time-varying random phenomena described statistically using tools like capital PDF, that means probability distribution function, and small PDF, probability density function, and correlation and covariance, which helps us understanding and modeling signals such as noise and message signals in communication system of random process. This is the definition of random process. Now come to the definition of random process. A random process, it is also called as stochastic process, is a process in which a random variable depends on both time and sample space. Time, how the variable changes over time, it says about the random process. In sample space, the random outcomes from an experiment, it can explain. So a random process is written as capital X of x comma t or simply capital X of t. Here S represents the randomness and t represents the time. That means for every random outcome S, we get a different signal. That means function of t. Now come to the different forms of random process. First one is when time t is fixed. You only look at the particular instant of time, the random process becomes a random variable because only randomness remains, represented as capital X of x comma t1. This shows the random value of the process at time t1. For example, noise voltage measured at one instant, but many differ each time you repeat the same experiment. Then we will set that when time t is fixed. Second one is sample space X is fixed. You are looking at one particular outcome, one experiment. It becomes a real function of time. It represented as capital X of x1 comma t. This means for one specific experiment x1, how the signal changes over time. For example, the waveform of one realization of a random signal. When both t time and sample space S are fixed. Both are given specific values, so it becomes a constant, represented as capital X of x1 comma t1. For example, the value of a signal at a specific instant in one experiment can when we can say that when both time t and sample space are fixed at a constant. This is the table for random process and there are some of the columns. First column is condition, next column is representation, third column is nature and fourth column is example. First condition is time variable and sample space variable. Its representation is capital X of x comma t and its nature is random process, for example random signal. Next one time fixed. It representation as capital X of x comma t1 and its nature is random variable. Example is noise at a particular instant. Next one is sample fixed. It representation as capital X of x1 comma t, and its nature is time function. And example is one noise waveform. Next one is both time and sample space are fixed, and its representation as capital X of x1 comma t1, and its nature is constant. Example is single value at a constant. Now come to the classification of random process. Based on whether time and random variable are continuous or discrete, we classify into four types. Type 1, continuous random process, and its time variable is continuous, random variable is continuous. Example, voice signal and thermal noise. Next type is discrete random process, and its time variable is discrete, random variable is continuous, and example is daily temperature readings. Third classification is continuous random sequence, and time variable is continuous, random variable is discrete, and example switching between discrete states continuously. Fourth type is discrete random sequence. Time variable is discrete and random variable also a discrete. Example, digital data, coin toss at multiple. Now come to the first type of random process. First type is continuous random process. A random process is said to be continuous if both time and the random variable are continuous over the entire duration. In this type, the random variable can take any value within a continuous range for all moments of time. An example is the fluctuation of noise voltage in an electrical circuit where both time and amplitude vary continuously. This is the waveform for continuous random process. It continuous waveform at any instant of time, then it is said to be continuous random process. This is the sample function of a continuous random process waveform. Now come to the second type, discrete random process. In a discrete random process, the random variable takes discrete values but time is constant or continuous. The random variable can switch only between certain fixed values while time processing continuously. For example, a digital signal that alternates between two discrete levels but exists continuously in time. This is the sample function of discrete random process. This waveform must be shown like a rectangular pulse at any instant of time. This is the third type of random process, continuous random sequence. A continuous random sequence occurs when time is discrete and random variable is continuous. The random signal is defined at specific time intervals, but its amplitude can take any continuous value. It is represented as a set of random variables defined only for discrete sampling instances. This type is often used when sampling a continuous signal without quantizing its amplitude. This is the sample function of a continuous random sequence. This waveform is shown like a discrete. This is the fourth type of random process. Fourth type is discrete random sequence. In a discrete random sequence, both time and the random variable are discrete. The signal is sampled at discrete time intervals and the amplitude is also quantized into discrete levels. This process is commonly used in digital signal processing. The amplitude may be represented using two levels of multiple quantized levels depending on the amplification. It is often obtained by both sampling and quantization. This is the sample function of a discrete random sequence, and it shows only discrete waveform at particular time like 1, 2, 3, 4 and so on. Sampling converts the continuous time signal into discrete times values, and quantization converts the continuous amplitude into a limited number of discrete levels. This is the sample function of a discrete random sequence in multi-levels. This is the application of random process. First one is communication system. Second one is digital signal processing. Third one is physical and natural phenomena. Fourth one is system analysis and control. Fifth one is signal detection and estimation.